My name is Volker Marten, and I started to get concerned about the problem about climate change a couple of years ago. It's already 18 years ago, and it happened that in a conference from a physician, a physicist, as you say in English, he made a presentation, and he said, by the way, with his hand in front of his mouth saying, and by the way, this whole climate stuff is a scam. I was in the front row and I heard it, and I was astonished because I believed that the whole climate thing up to that time, it was 2006, late December 2006. And so I started to look at the literature, and I started to dig in. You might appreciate to know that I started studying. I have an apprentice. I'm a carpenter. I'm an artist, and I worked in different fields. And I consider myself as maybe you might say, a citizen scientist, because I dig into the problems. And this is one of the things I did. I took my old books and looked in them, and I saw that there was something wrong. There was something something fishy. And so I got involved in the problem, and I had conversations with a great deal of scientists, also very friendly responses I got, even from John Clauser and so forth. And I am prepared to start with my presentation now. And I called it the climate change delusion. Maybe it's an old phrase that had been already lanced a couple of times, but it still holds, I guess. It holds water. And I call it the origin, rise, and the prevented fall of the CO2 climate hypothesis. Now, we might ask, why has there been such a bitter dispute about climate change for such a long time? Everybody discusses it, the media talks about it, and everybody is concerned. And especially, as I can see, I got my daughter, luckily, through high school without her having been influenced or manipulated too much. I was already at that time talking with her about these things. So, and I answer this question by saying, because the climate hypothesis put forward 129 years ago was scientifically refuted in 1999. Since 1999, we have been confronted with sideshows and details of a refuted hypothesis. Now we're confronted with young people today who say, listen to the science. And this phrase, the science, is remarkable because science is a procedure, is a technique, is a method of investigating problems, scientific problems. And so it is not the science, but it is science. And if we say, listen to the science, this is something that you would say somewhere in a oppressive country, maybe in the GDR, you might have said something like that. I like to say, let's look at science. And there is this claim nowadays of human-caused dangerous climate change. And there are a couple of points that you can hear everywhere. I just gathered them up and will list them here. Carbon dioxide, first of all, is the most important greenhouse gas. Second, without humans, the concentration of CO2 in the atmosphere would remain constant at the level reconstructed from the ice cores. 3, the amount of background CO2 in the atmosphere determines the average temperature on Earth, which has increased since the Industrial Revolution. And 4, since 1958, the Keeling curve has shown that humans have continuously increased the global background CO2. And 5, therefore humans determine the global temperature. And 6, consequently humans control the global climate. And 7, thus the policy of taxing and regulating carbon dioxide emissions is science-based and necessary. Now, there is a saying of Igor Shafarevich from 1980. He said, the decisive characteristic of scientific work is the uncompromising pursuit of truth for its own sake. And this is what we therefore invented in the Western world since the Enlightenment, the scientific method. And the scientific method, how does it work? We have, first of all, the field of science, and we put forward an hypothesis, which then has to be tested, and then it might be verified. And then after that, it can become a theory. And of course, this theory may be and should be tested every once in a while, or should be questioned. Because as Richard Feynman said, science is the belief and the ignorance of the experts, and so experts have to be questioned and their thesis. Now, if the test turns out to be false, or that is to say that the hypothesis is falsified, then we have to go back to the drawing board and formulate a new hypothesis, which then has to be tested, of course, and so forth. And this is what we call the scientific method. Now, if the test fails and the hypothesis is falsified, refuted, and nevertheless the falsified hypothesis is carried on, this means it leaves the field of science and it passes the scientific method and enters something which we call pseudoscience. This is not any more science. It looks like science. It is not any more science because it violated one of the core values of scientific endeavor. It's the falsification. So this is a no-go. This does not work. But pseudoscience penetrates in all other sorts of social rounds, in the media, in politics, in jurisdiction, everywhere. Pseudoscience penetrates, and even it goes back into science, into the scientific method. It violates the scientific method, and this is what happens with the scientific method. If pseudoscience takes it over, it becomes contaminated by false assumptions and hypotheses that become theories without the test, verification, or falsification. Now, we look at the CO2 climate change hypothesis, and it started in 1896. And this is the year in which Svante Arrhenius, a Swedish chemist and physicist, he became Nobel laureate in 1903 because he was a friend of Alfred Nobel, but this is another story. And Svante Arrhenius assumed that the ice ages were predominantly controlled by atmospheric CO2 and water vapor. Now, he had this paper in 1896, which I have here. You might stop and read a bit if you like, or look up the origins or the sources. And then in 1906, Svante Arrhenius wrote another paper because his colleague, scientific colleague in Sweden, Knut Ångström, just trashed his first paper in 1896 and said it wasn't even worth talking about. And this enraged, of course, Svante Arrhenius, and he looked at the issues once again. He corrected a couple of things, and he put this paper, published this paper again, in German this time. So it's easier for me to read, although it's a scientific paper, and a couple of things I don't really grasp fully. But it is enough to understand that he, as his title says, he says the probable cause of climate fluctuations. So we are looking for a cause. This is important. Now, fast forward. In 1938, there was a quiet time meanwhile, but in 1938, Guy Stewart Callendar came up with the idea that this might be a very nice, very good idea. as Svante Arrhenius thought it was a good thing that the world would be warming by burning fossil fuels, also Guy Stewart Callendar thought it was a good thing, and he even wrote in this paper that it might even delay the onset of the coming ice age for a while, brutal ice age or something like that, he said. So was happy that it might happen. And this is what he did. This is a chart of the data points of carbon dioxide, which he selected. And it is these below here. These show an increase from around 1860 up to 1950 or so. And it had a clear increase in the values. Now, what about the other values? These are all values that had been known up to then. For example, from Nicolas Théodore de Saussure, a Swiss scientist, who had one of the best methods. He chose out of 7 different methods the best one. He got every time quite similar results, but these are all local measurements. This is no background CO2. These are all local measurements. But these measurements here, they range from 350 to 550 parts per million. Guy Stewart Callendar left them out. And this is something that a group of scientists in Finland, Fonselius et al., 1956, showed in their paper. And they showed that a Callendar selected a couple of values of measurements which fit his hypothesis. Now, in 1955, there is a Canadian physicist, Gilbert Plass, who said, "Oh, hold on, we have to look at this issue once again. We have to understand a bit more about carbon dioxide and temperatures, and the best thing would be just to make a test until the end of this century, which was then 1999, and to look at all the data and understand what is going on. And of course, we have to look at CO2. We don't have enough CO2 measurements. We need better CO2 measurements." And so this was done. And in 1958, Roger Revelle helped Charles David Keeling to set up his Mauna Loa Observatory for carbon dioxide. And this is on the highest volcano, active volcano on Earth, from the bottom to the top, the highest. And these are the values which everybody knows, I guess. These are the values of carbon dioxide bouncing up and down from summer where it is low and winter where it is high, because the plants release carbon dioxide and so forth. And it goes straight up. There is not a dip anywhere obvious, not even during COVID in 2021 and 2020. There is no change. So carbon dioxide went up. And you can see that the Mauna Loa, the volcano, was active because they had to shut down the station, or even it was close to be shutting down in 2022. And so they had to take the measurements from a nearby mountain called Mauna Kea. Okay, this is but from 1958 on, carbon dioxide went up, but the temperatures went down from the 1960s to the 1970s. I remember that. I was born in 1955, and I can remember these harsh winters very well. In 1978, it was from winters 78 to 79, whole Europe was freezing, and there came a cold spell which just burst all water pipes in my flat in Hamburg, where I lived at that time. And so it just came out of this harsh period, and the temperatures rose again. Now, we have to ask ourselves, what is this cause? And what is the cause and the effect relationship between the greenhouse effect and the observed warming? Now we have 1987, and for the first time we have the data from from the ice cores, Antarctica. And these came from Barnola et al., 1987. And one could see clearly that there's a correlation. There is carbon dioxide and temperature going up and down in the same, or more or less, the same manner. And this was, of course, known at that time. There was a correlation. And in 1988, Jim Hansen delivered his congressional testimony on the hottest day of the year, as they found out, or they hoped to find out, and did it that way. And Hansen said he had delivered a speech already in 1986, but he wasn't sure. And then he was invited again by Timothy Worth, and Al Gore was also present, I remember. And it was then that he said, okay, but a couple of weeks before, he said, I wasn't sure about the cause and effect relationship, but by weighing the positive and the negative, I decided to speak out. And so even not being sure, he spoke out and said, there is a 90% or 99%, whatever, chance that we are in a warming spell, and that carbon dioxide is responsible for that. Now, the cause and effect relationship between CO2 and temperature had not yet been clear. It wasn't clear. In 1989, John Gribben wrote in the New Scientist under the title The End of the Ice Age, where carbon dioxide leads, temperature follows. So it was clear for them. Case closed, science settled. I took this graph and took another graph. These are two different ways of looking at graphs. The upper one is from Barnola, who was a glaciologist, and geologists do it the same time, the same way. They proceed in going down, and this means that they're going back in time. This is why this graph shows that it is going right down. So the oldest measurements are 160,000 years old. And I've reversed, or this is another chart which we read today in this manner, that we read from left to right the time as it proceeds. Now, the IPCC, its first assessment report in 1990 was set up, or the summary for policymakers said, we do not know cause and effect. Measurements from ice cores going back 160,000 years show that the Earth's temperature closely paralleled the amount of carbon dioxide and methane in the atmosphere, but we don't know what is the cause and what is the effect. And Aaron Wildowski, who wrote a very good book in 1995, But Is It True? A Citizen's Guide to Environmental Health and Safety Issues. And he also wrote in 1995 still, no one knows which came first, the chicken of carbon dioxide or the egg of higher Earth temperatures. And I'd like to read this, although I don't like to read my own charts here, but this is important. This graph illustrates long-term fluctuations in global temperature and atmospheric carbon dioxide from Vostok ice core samples. Observe how one tracks the other. It seems highly unlikely that future patterns will be different. Now, in 1999, we have the revelation. There is the paper, the first paper, I guess it's the first paper from Petit et al., 1999. And there are a couple of other papers that show the same thing. Carbon dioxide and temperature are closely related here. And we can see clearly from this chart from Petit et al. That carbon dioxide always follows the temperature. If you look at the movement bouncing up and down carbon dioxide and temperature, we can see that carbon dioxide takes longer to descend, to go down again. If we see in the second column, there's the number 23, which is the time that carbon dioxide took to fall down again, to descend. And below we have temperature. It took only half as much. or yeah, 60, it says, in any case, it's much less. So carbon dioxide always lags temperature. This is known, everybody knows it. Fischer et al. 1999, Muddelsee, Monin, Caillon et al., and I will come to Caillon et al. 2003 later. Now, we know from 1999 on, since Petit et al. 1999 and many other studies, it is known that changes of carbon dioxide always follow temperature changes. Second, carbon dioxide remained at its minimum when temperatures started to rise at the beginning of an interglacial. And three, carbon dioxide remained at its maximum when temperatures started to fall at the beginning of a glaciation. And four, thus, there is no feedback amplification from carbon dioxide to be seen in the data and the graph. It is not detectable. We cannot see it. There is the diction that carbon dioxide follows temperature, but then it rises, and so the temperatures follow carbon dioxide. And this is something that will be discussed a great deal in the future. And five, it is highly unlikely that future patterns will be different. This is what Aaron Wildavsky said in 1995. So we can assume very confidently that this pattern will continue. And therefore, the CO2 climate change hypothesis put forward by Arrhenius, Callender, Plass, and Hansen has been proven wrong according to the scientific method with data since 1999. So it is not the case what Arrhenius and Callender thought, that carbon dioxide would show that the temperatures would rise. This is not the case. But nevertheless, in 2006, Al Gore, in his movie An Inconvenient Truth, set up his graph, and he took the Caillon et al. Graph from 2003, and then you can see the red line is carbon dioxide and the temperatures below. Al Gore knew that the temperature rose first, and then carbon dioxide came. But what he is showing insinuates that carbon dioxide leads, it skyrockets, and then the temperatures naturally will follow. This is what he makes the audience believe. And even climatenasa.gov says the same thing, although they cautiously left out the temperature. They just put in the carbon dioxide. And this is from 2008 to 2010. And we can see here something which I will talk about also. We can see that it is claimed that for millennia, atmospheric carbon dioxide never been above the line that is shown there, 300 parts per million. And for 80% of the time, it is said that carbon dioxide never exceeded 280 parts per million. Now, every biologist knows that plants don't survive very much at 180 parts per million, and they thrive at higher carbon dioxide amounts in the atmosphere, up to 4,000 parts per million, at least 2,000 parts per million, and so forth. So carbon dioxide is not that bad. Just to show you, I have my device here, and I'm looking at carbon dioxide. This is what it has right now in my room. 747, 750. If I breathe against it, it will go up immediately. Let's see. So there's 763. 2,000. So this is what happens, and I'm still alive. Everything okay. Don't worry. Now, maybe you can see the device up there. Now, if this is the case, that plants don't survive if it is below 150 parts per million, then I clearly say that this chart for any layman must have something wrong. There is something wrong here. It's in my guts. I feel that there's something wrong here. It can't be that we change carbon dioxide in the atmosphere that much. And we will see what will happen. Now, Christopher SX, whom I like very much, a Canadian statistician and mathematician, I guess you had him, Tom. He said, instead of policy based on science, we have the weird inversion of science based on policy. And as Thomas Henry Huxley said, the great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. And I claim the great tragedy of climate science today, since 1999, the beautiful CO2 climate change hypothesis has been kept alive, despite it having been refuted by ugly ice core data. Since then, computer models and climate cult believers have been fed with horror stories, all based on the disproven CO2 climate hypothesis.
I really enjoyed the CO2 meter in your office. I love that. But...
Yeah, I have to show you. I have three, just to be sure. This is the middle. I have one high, one low, and one in the middle. And this is the best one. I have two others. This one shows another.
So I can't read that one right now. What is it?
This has 756, and the other one I have is 929. And now it says, the air is getting a bit bad. Well, not for me. It's okay still. everything fine. And the other one is turned off. It's not working right now.
I was curious, have you tried measuring CO2 levels outside of your house and seeing how they vary from time of day, stuff like that?
Very much. I have looked at CO2 in different parts. I have looked at CO2 in different times of the day. In northern Germany, I looked at it while traveling to Austria. I looked in the Alps, and I was astonished to see. I took photographs of this device, of this measurement of the values, and it went down to 260 parts per million. The lowest value I've ever measured was on a pass about 1,000 meters high in Austria. And other values go from 350 up to 550, even 600 parts per million. But these are local measurements. There are no background values. They are specific, detailed measurements at a certain time, at a certain point. And I think that they have a value, that they show what we can expect from measurements in the past. And this is the second part of my talk, which I would proceed to that part, if it's okay.
Well, one follow-up question. Does it make perfect sense to you that the parts per million of CO2 would be low at altitude?
It has to do that the vegetation was very down at that site. There was no economy or industry around. There were no crops, no fields, okay, yeah, you understand.
Okay.
It was very remote, a local, very remote site.
Okay.
Okay. I like this saying from Immanuel Kant, who says, well, I'd like to just slip it in. Enlightenment is humanity's escape from self-imposed immaturity. Immaturity is the inability to use one's intellect without guidance from others. Immaturity is self-inflicted when it is caused not by a lack of understanding, but by a lack of resolution and courage to use one's intellect independently. Sapere aude. Have the courage to use your own intellect. So this is Kant, and this is what guides my findings or my endeavor. Now, we have the policy-based science. And this is what Christopher SX said, the science based on policy. And don't know if I should say pseudoscience, because if you look at the scientific method, we left science already. And now we look at these charts. The one on top, from Petit et al. 1999, and the ones that we have right now, going back 800,000 years. Petit et al. Was 400,000 years. So we have the same pattern going back. And now we have this pattern, and we look at these values here, and they skyrocket. And as I said, there's something fishy about it. It is an extraordinary claim. As Carl Sagan said, extraordinary claims require extraordinary evidence. Now we look at the ice core proxy data versus the measured temperature. And for the time before and after 1958, when the Mauna Loa Observatory was installed, a background CO2 had to be established to make a hypothesis again, or to make a claim. You need one value to compare it to the temperature. Now we have these values here. It's a certain day, which I just picked it up at the Keeling curve. You can Google it. It's for everybody open to see. And we have these values here. And what about the other values as I showed? I'm insisting on this because there's something wrong about this. Because if we look at the value of carbon dioxide in the year 1828, around 1828, we can see that it is supposed to have been 282 parts per million at that point. And I would like to dive into historical measurements of CO2. And I would like to look at Nicolas Théodore de Saussure. He was a Swiss chemist from a very famous scientist family. His father was Horace Bénédict de Saussure, and as a young ongoing scientist, Nicolas accompanied him, and they went up on Mont Blanc. They went up to Mont Blanc to measure carbon dioxide also, and oxygen. They measured a whole bunch of things. And Saussure, Saussure, Nicolas Théodore de Saussure, he is one of the major pioneers in the study of photosynthesis. This is what Wikipedia says about him, but he's more. He wrote this, or he was invited to present his values of, or his measurements of carbon dioxide, which he had taken in the years 1827 to 1829. He took them from 1806 already on, but he said, I would like to publish only those where I had taken also measurements at night. He wanted to know how carbon dioxide would change during the night. So he was very specific with this, and this book shows on the first couple of pages his analysis. And he writes about his techniques of methods of measuring. 7 there were, and he picked the one he found that would be the most precise, the most accurate. Now, this is a photocopy of one of his papers, of his book. And to understand what he wrote here, I just transcribed them. So we can see here the values. This is the presentation of 1830. And we can see from late 1826 on up to late 1829. So we have these 3 years. From 1826, there's not very much, but we can see the values, and there is a movement of the values. 1827, there were higher values, and they went down. And in the year 1829, the 4 last line, we can see that it was the lowest at that time. But the average still stayed in Chambéry. This is north of Geneva, a small town, countryside north of Geneva, not far from Lake Geneva. And we can see that the average was 460 parts per million there. And on the lake, it was 439 parts per million. So he went onto the lake, And he described explicitly how he measured it, how he went outside, how high it was, the device, and so forth. And it was very complicated, this method. I published also, or not yet published, but I wrote about his method and his technique. Now, these are the measurements. And if we look at them once again, as Callender selected them, they are far away from what de Saussure found out. If we look at the other values here, they looked at it as points per 10,000 volumes of air. And now we look at them in a different way. And they are all over more or less around 4,600 parts per million. And a climate scientist wrote to me, nobody will ever take Saussure's values seriously except climate deniers. So this is clearly a threat to the hypothesis or to the dogma, because it is no hypothesis anymore. The hypothesis is refuted. This is a dogma. This is a danger for the dogma, these measurements. And the Encyclopedia Britannica in 1842, this is 12 years after this publication from Saussure, they took up the values that Saussure had taken, the Encyclopedia Britannica. His name, Saussure, wasn't mentioned, but the values are exactly the ones that he had taken, and he was famous for that. So we have the values of 415 parts per million, and the greatest value was 574 parts per million, smallest 313 parts per million. So we can see there's a great variation of carbon dioxide depending on time of the day and time of the year, and even location. And even if it's raining or not, if wind or not wind, and so forth. Now, the question is, what does the measured background CO2 mean in relation to the daily, seasonal, and local variation of atmospheric CO2? We have to remember that the background carbon dioxide is the holy grail, is the cow, the holy cow. And it is the measurement that dictates all measurements around the world. And now we have to look at them for a moment. Just to slip in 1993, there was the 4th International CO2 Conference in Carqueiranne in France in September. And they wrote about Nicolas Théodore de Saussure, that he took up these measurements. He was admired for his work, and he had these values, which they also quoted here: 3 to 15 parts per million to 540 parts per million. Then there are measurements in Geneva, where it's a bit polluted, 468 parts per million. So these measurements are much higher than we are told they are, or they have been. Now, I like this quote from Werner Heisenberg. What we observe is not nature itself, but nature exposed to our method of questioning. And therefore, this is a chart or a map of the world of carbon dioxide. And we can see here the measurements. And there's a mean measurement, not a low measurement, a mean measurement of 385 parts per million, around about, and maximum of 455 parts per million. This is in March 2011. And this is from a source which had been taken over by Copernicus in Europe, and they don't show it anymore. I have a hunch why they don't show it anymore. And this is another chart that shows the same thing, but they still carry on saying greenhouse gas concentrations regulate Earth's temperature. This is flat out wrong. This is a lie, and they know it. It is. I don't know why this is happening. Now, we know this already. And one thing from Carl Sagan, so the central lesson of science is that to understand complex issues or even simple ones, we must try to free our minds of dogma and to guarantee the freedom to publish, to contradict, and to experiment. Arguments from authority are unacceptable. I agree. So this is one part, a second part. And then I have another quote from Charles Mackay, who said, I like this quote, "Men, it has been well said, think in herds. It would be seen that they go mad in herds while they only recover their senses or slowly, one by one." You maybe probably all know this quote, but I like to quote it once again because we know this. Now, there's something else that I would like to show here. During COVID, there was, of course, the lockdown, and CO2 emissions plummeted. But you cannot see it in the graphs here from Mauna Loa. There is not a change at all. And this is another chart which I'd like to show how small carbon dioxide. This is from John Christie. I hope he allowed me or allows me. I had conversations with him to show this. And this is carbon dioxide here, this tiny amount. And so therefore, I'd like to just ask everybody to stop for a moment and think for a while and just reflect and look at a couple of data. It's not very difficult. If you can see this contradiction, it's enough for a layman to understand that something is wrong. And this is something from Ole Hundum in Sweden. He shows another graph that shows that carbon dioxide today always carbon dioxide always follows the temperature. We can see that the blue and red rise first, and then green, carbon dioxide rises afterwards. Though this is a clear sign of a reverse understanding of carbon dioxide and temperature. And with this chart from Ole Hundum, I like to conclude my presentation.
Do you want to expand at all on why you don't believe that Antarctic ice core CO2 data?
There is a problem with the ice cores, or a couple of problems, because if you go down in the ice cores and you measure the pressure rises and rises and rises, and we have up to 200 or more than 260 atm, atmospheric pressures. So it is very high, and at that level, carbon dioxide is not anymore as a bubble. They say it is a bubble. It's not anymore a bubble. At high pressure, carbon dioxide first becomes dry ice. I don't know how you call it in English. It's the massive form of carbon dioxide. You use it for making steam and foam when you in theaters.
Yeah, I think dry ice. I don't know if there's another name, but dry ice is one.
Trockenice in German. Trockenice.
Okay.
Okay, and at the bottom of these of the ice cores, carbon dioxide makes a what do you call it? A reaction with the H2O molecules and becomes a so-called cathrate, which is a massive part. And even if you think about it, that CO2 from 800,000 years ago, and there are bacteria in the ice and so forth, there are reactions and changes of the chemical composition of all sorts of things down there. And carbon dioxide is one part of that. And I am not the scientist to prove this, but I would like a couple of scientists to maybe question it or have a reason to question it if this is correct or not.
Okay. And then it sounds like you're completely disagreeing with the idea that CO2 is well mixed in the atmosphere. They're constantly telling us it's well mixed. But right now, at this moment, there's lots of different levels of CO2, even outdoors around the world, correct?
Right. If you look at NASA has a video which I thought I would show, but it turned out to be a bit too complicated. But NASA has a video that shows the fluctuations and variations of carbon dioxide throughout the year, and it is enormous. There is a huge change of carbon dioxide. These are the values of carbon dioxide. I can't see anything well mixed here. These are hotspots of carbon dioxide in the Amazonian, in Central Africa, in East Asia, in Europe, and then there's less carbon dioxide everywhere else. And to take one measurement and claiming that it is the knob, the control knob of temperature, seems a bit strange.
Yeah. What do you think is going on with that Keeling curve data then? Do you think they're throwing out tons of outliers to make it look smooth as it does?
Of course they are. If you look at the data, there are scatter plots. These are called scatter plots that show all sorts of data, ups and downs and up and down, and they take the middle curve to show what's going on. And this is a constructed value. It is not the measurement, but it is the way we are looking at it, as Heisenberg said. It's the way we look at it from a scientific point of view, as we like to see it. We like to see it that, or the alarmists like to see it, that the carbon dioxide is a nasty, evil gas that we have to control, and now we have to know how much is there, and so forth. And it just is not correct to deal with carbon dioxide in this manner.
So right now I'm looking at the Keeling curve page, and it shows the data from about just before 1960 to 2025. If you were able to measure CO2 all over the world and tried to put up a plot like that, could you even make a plot that would make any sense for the data, the average from, or you just couldn't do it? It's scattered all over the place?
Good question, Tom. I don't think so. I don't think there could be a reasonable chart. It would fluctuate, and just the way that this NASA video shows, it's constantly moving. You cannot define a certain amount of carbon dioxide anywhere. It just moves from day to day that quickly that it is not possible to even to follow carbon dioxide in the atmosphere. And this is why, yes, I dare to say I'm not a scientist. I'm a layman. But as Freeman Dyson said, the people that matter are not the experts, but those who know when they're framed or scammed. And I like to look at these claims, and question them with going a step back and just thinking about scientifically, and not following this narrative that has been put forward, and nobody who contradicts it is allowed to speak openly. And so this is great that I have the possibility, and the others, to talk here and say that. In the mainstream media, I would never be able to say this.
So it's probably the same question again, but if you were to measure the CO2 levels just in your yard over the last 10 years, do you think you'd see any trend at all, or you'd see any effect whatsoever from the lockdowns for COVID, or it's not that?
That is a very good question. And I think, well, I didn't do what Nicolas Théodore de Saussure did over 3 years, just measuring constantly day and night and so forth, and the whole year through. If I would do this, I would find something similar as Nicolas de Saussure had. These are measurements, just an example here. These measurements on the left, he took hundreds of measurements and just found out what could be, is there just to detect a movement up or down, and maybe one could find out something. And I'm not that critical. I believe that on Mauna Loa, Ralph Keeling, who's managing it right now, is a sincere and honest guy. He wants to know what's going on, but he has a heresy. He has this heritage from his father. He has to do this, and he would never accept any doubt or question. So, and as I know that the administration, the new American administration, wants to look at Mauna Loa and the data and so forth. And there's Roger Pilkey who says, stop, we need Mauna Loa. There are important measurements there that have been done, so we can't just trash it and throw it out. We have to look at it. But I think that something has to happen in Germany, what is happening in the United States, and that is the possibility, you call it the red team, blue team. We don't have this in Germany. We have one monopoly of state science that is being carried out, and from left to right, everybody believes it, that this is a danger, and Trump is dangerous because he doesn't believe in it, and so forth. And I hope that if reason comes back, that we would start and just start mixing the cards again and starting the whole thing maybe once again and looking, maybe making a reset and looking at the values to see what is really happening there.
Could we jump back to your slide number 22 again? That seems like it's one of the key slides that people are constantly putting this up and saying, oh, those dots there, it's okay to throw those out and we can just use, they just use the circled ones? That's what Callender did?
Right. This is what Callender selected. And this is, you can see it here, Fonselius published a paper, I have it here in my computer. He published a paper and said, what Callender said, in Finland, it's not true. We had much higher CO2 values. This is what Fonselius said. But he is very balanced. He is very, very moderate in his criticism. But he says, this is something that was selected. And we have to remember that Guy Callender was a layman, just as I am. He was a steam engine engineer and an amateur meteorologist. I can call myself that the same. I'm interested in these things. And it was this layman who brought the data that was picked up by scientists afterwards who claimed they were scientists. Nobody was a climatologist at that time. There wasn't anything of the sort. And so they picked it up, but they picked up what Callender selected because it served their narrative. And the other values here, all the ones from Saussure and all the ones that had been published in encyclopedia, in the Myers lexicon from 1841 to 1896, all of them had these measurements, and afterwards they were thrown out. They were just not accepted anymore because they said they're not background values. But these here are not background values. They're selected local values. And so this is the beginning of he was very interested in an interesting guy. And in this paper here, I don't have the pages here, but it would be difficult to show them. But there is a discussion in this paper. You can see here the source, and you can find the paper, and there's a discussion among meteorologists at that time, known meteorologists, who were critical and said, oh, great deal of work and wonderful, but we have to look at it a bit more, and a layman, but let's look at it. And they were very open about it, and I think it was great and wonderful that this paper had been published and was accepted as a discussion point. This should be done today also, the same thing.
So I do hear some climate realists talking about isotopes of carbon, that they can tell that humans caused an increase since 1850 because of changing ratios of carbon isotopes. Do you have thoughts on that one?
Yes, I know that that's the case. I didn't dive into it too much. But there is a contradiction. There are two ways of thinking it. You look at the if you look at the theoretical amount of carbon dioxide, and then you look at the Keeling curve, and you can see there is a steady increase, and all also critical scientists say this is all man-made, human-made. Okay, I had discussions with them, Gregory Whitestone and so forth, and Willie Stone, and I find it interesting and important. And I am not claiming here to know what is the truth and what is not the truth. But if we see here that the amount of carbon dioxide during the whole time of COVID, as we remember, here, it didn't change a bit. So if we think think of it for a moment, if you look at the graph of Petit Data 1999, we can see that that carbon dioxide rose later, and therefore we can assume, and it was 400 to 800 years later that carbon dioxide increased. We have up to 60 times more of CO2 in the ocean. So if we know that the oceans have so much more, and by way of the so-called Henry's law, there is a balance between the CO2 content of the atmosphere above the ocean and in the water. And so there is a constant movement of carbon dioxide up and down, and it tries to keep a level. This is what nature does. It tries to keep it. It never gets to a complete level, but there is this movement always up and down. And there are too many questions for me to be answered still, to explain why carbon dioxide. And they say, okay, carbon dioxide. NASA wrote that we can see that didn't make a dent, that didn't change anything. So we have to restrict carbon dioxide even more. So it won't change anything. And if you look at all the years that carbon dioxide was diminished, in the United States it went down. Only in Asia, in India, China, and so forth, carbon dioxide still rises. But although it has been lowered, the amount of carbon dioxide, there is no change in the atmosphere. And this is something we can think about, that maybe the amount of carbon dioxide, this steady growth, this continuously steady growth, that we can say maybe it is something that started or that was implemented 400 or 800 years ago. The medieval warm period, when it got warm. Maybe we're warming since then. This in the charts, in the data, we can see it was the case. Why shouldn't it be today?
Do you have any thoughts on what the CO2 level might be on the roadside by a busy highway? Do you think it's much higher there, and possibly the plants could benefit from the additional CO2 from the cars driving by?
So, Tom, now you have to tell me which road. If you look at California, a road in California, or a road in Dubai, or in Reykjavik. Okay. So, of course, as they say, a diesel engine sucks up air that is dirtier than the one they pump out. So it's not the cars anymore. It's more or less the industry and so forth. Think of it for a moment. In Sweden, they have 60 gigatons of CO2 every year emissions. In Bangladesh, they have 70 gigatons of carbon dioxide emissions by breathing. Really? This is the breath of the people. It's more than the industry in Sweden. And there's a comparison with the 280 gigatons from China compared to the 180 gigatons in Germany, or what it is. Maybe I'm wrong with that. Don't quote me on this. But I mean, if you look at it everywhere, if you look at the whole picture, you can say that are we supposed to pay for our breath in future with the taxes? This is crazy.
Do you think that there is something to talking to your plants? If you have a house plant behind you and you go near it and talk and blow on it, that additional CO2 is a benefit?
Coming from a family of landscape architects, I can assure you, yes, talk with your plants, because if you breathe, you saw the numbers right now. While breathing, it went up from 700 parts per million to over 2,000 parts per million. The plants are dying for more carbon dioxide. They evolved. They started life when there was much higher carbon dioxide. They need more carbon dioxide. You know all the stories with the greenhouses where carbon dioxide is pumped in. Of course, carbon dioxide is more than plant food. It's the basis of our life here. Carbon dioxide is the most important gas besides water or oxygen and water, of course. It is, without CO2, we won't live. We have to repeat that again and again, because the poor guys, the poor children in the street that glue themselves to the streets don't know enough how they have been misled.
So then also there's this story that the CO2 we admit today is going to be up there for 1,000 years or more. And then some other folks say maybe it's more like 5 or 7 years. Do you have thoughts yourself on CO2 residence time?
Well, I am biased in this question because scientists like Hermann Harde said it's only 4 years, and they checked it and measured it. And I can't say I can prove it. I can't say if it's true or not true. I know that the alarmists say it stays there for thousands of years. But as we know, that the carbon cycle is a continuously evolving, changing cycle where carbon dioxide has all sorts of jobs to do. We breathe it out, and our plants grow better. Wonderful. This is okay. The oceans get warm, they breathe it out, and in the North Pole, carbon dioxide is sucked up because the water is colder, and because of the Henry's law, or it is the Henry's law. In any case, cold water can absorb much more carbon dioxide. So there is a continuous movement of carbon dioxide, and to try to fixate it into one narrative, and that it is the control knob of something evil that we're waiting for. This is more religious than it is scientific.
How about this idea that Patrick Moore has suggested that maybe humans have saved life on Earth by releasing CO2 into the air and keeping it in the atmosphere? And as time goes on, naturally, without humans, that the carbon might get locked into limestone and just slowly go down until life on Earth perishes. Is there anything to that suggestion?
Well, I like the way Patrick Moore describes it, as he shows that the carbon dioxide had been steadily going down. And so it just crashed, almost crashed. And then suddenly humans came and started emitting carbon dioxide. And finally it just went like an airplane that just touched and went off. We just went out of this disaster, and maybe carbon dioxide will save us. And where it goes into limestone and so forth, the ocean, it goes to the bottom, sinks and forms limestone. And this is what I have here around me. We have limestone here everywhere. And this is all the CO2 that had been in the air is now in this limestone here, I know. And this is the way that carbon dioxide went down. And I believe that there is something to it, what Patrick Moore says.
I should know this, but what would be the natural process to get it out of the limestone and back into the atmosphere naturally?
Oh, I don't know. By burning. You burn limestone, you make chalk out of it, or not chalk, you make calcium out of it. You use it, and even the process of cement making emits carbon dioxide. So yeah, there are different ways that carbon dioxide plays a role with limestone and so forth. Yeah.
Any other points you'd like to make before we go ahead and wrap this one up?
Well, I think we talked about a great many of problems, and I think it's that's fine. I think I got my message across, and if anybody has questions, would like. If there are questions, I'm happy to answer them, but I would like to have them very civil and to have them as a discussion and not as a accusation, because what I showed here are the data, and if somebody has something contrary to say, I'm happy to hear about it. Thank you.
All right. Thank you very much. And would you be okay with sharing your slides via PDF on my Substack page?
I will. Of course. Yeah.
Okay. All right. Thank you very much for doing this. I hope to have you on again soon. Volker Marten.
Thank you, Tom. Thank you.